Good afternoon. Today we are going to work through 2016 paper 2, so have your calculator ready. Remember at the end, or hopefully by the end of the day on Sunday, you've uploaded your work from Monday and Friday's lesson. Upload what you can, and remember we're expecting you for each double period you're spending approximately an hour and 45 minutes or thereabouts, okay? If you are finding you're taking a lot longer than that, do please let me know, but I expect the level of ability you're at, 2 20 minutes videos plus 2 approximately 20-minute short exercises to do really should mean that the double period is plenty for you to do each. Okay? Right, let's get restart. Make sure you get your calculator ready. Number 1, drinks manufacturers reducing the sugar content of one of their fizzy drinks. So they're reducing it by 8% per year over 3 years. Okay, so let's see. 8% per year reduction. Right, it's currently 35 grams. So we need to reduce, okay? We're working at a future value, okay? Now the way that I would do this, and again, see if your maths teacher is showing you slightly different, pause the video, just come back and double check, okay? Because I'm working at a future value, I would always multiply. If I multiply by 1 point something, it would increase by 8%, 1.08 for example. I don't want an increase, I want a decrease. So this is where I change it in a decrease. I multiply it by 0 point, and we pretend we're taking away the 8% from 100. So we're multiplying by 0.92. Basically working out 92%, okay? But we're doing this for 3 years, so that's why our power is a 3. That is a number 3. There we go, that's better. Let's get your calculator. Let's see, 35 times by 0.92 to the power 3. 27.25. Something like that. And as is the case of any question where you have an answer that is a decimal, I would begin back to double check to see if it mentions anything about rounding. Does it mention anything about rounding? No, it doesn't. It doesn't say anything like that. Please do put the units in. I'll say 27.3. The answers, it doesn't matter about rounding. The units, this is grams, I think, isn't it? Yeah, 35 grams. There we go. Okay. Number 2. Right, I remember when this one came up in the exam paper. Oh, you won't believe, question 2, how many people got this mixed up. Right, so a pollen sample weighs 12 grams and it contains 1.5 blah 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 times 10 to the power 9 pollen grains. What is the weight of 1 pollen grain? Right, you know the weight of 1.5 times 10 to the power 9 pollen grains. You're trying to find the weight of one of them. Okay, so the number of grains and the weight. Right, so 1.5 times 10 to the power 9 grains, that's how many grains we've got. That weighs 12 grams. We're trying to find the weight of 1 pollen grain. Okay, so imagine this question told us, let's see, 5 pins weigh 20 grams. To find the weight of 1 pin, you do 20 grams divided by 5. If you know the weight of 5 things, you divide the weight by 5 to get the weight of 1. So what are we doing? We're dividing 12 grams by the number of pollen grains. Okay? 12 divided by, I would put the 1.5 times 10 to the power 9 in a wee bracket. You just double check how your calculator works. When I do that, I get 8 times 10 to the power negative 9. Okay, and that's the weight, which is in grams. Also, just double check. Rounding, does it mention anything about rounding? Find the weight of 1 in grams. We've got the weight. That's a negative 9 power. Give your answer in scientific notation. It's already given us it in scientific notation. Okay. Number 3. Let's see, the diagram below shows a parallelogram. Parallelogram, remember, opposite sides are the same length and they're parallel. Vectors that are opposite each other are given the same letter, okay? So that vector u across the bottom, which is A to B, is also the same for D to C at the top. Right, okay, express B to D. Basically, how do you get from B to D? That's what we're looking for. Now, we can only go along the sides where we know the values of the vectors were given, okay? As I mentioned, this one here, because it's parallel to this one, is also V. Okay? This one here, I'll see if I can do it in a different colour. Yes, let's go with that. This one across the bottom in that direction is vector U. That means also this one across the top in the same direction is also vector U. Okay, so it's this information that's going to help us work out the answer. Find B to D. So start at B and go to D. It doesn't matter which way you go round, it makes no difference. We'll go this way, then that way. Okay, start at B at the bottom, we're starting here. So it's going to be V, which is in the right direction. Just double check the arrow. So that's vector V. But the top, you'll notice we're going backwards. Vector U is going from left to right. However, we want to go from right to left. So that's actually negative U. If you go in the opposite direction, it's a negative U. So the answer to this question is actually V plus negative U. You add your vectors on. However, it's actually best to say just V take away U. Okay? Number 4, and again you'll notice we have hardly used the calculator, not much. Just because it's a calculator paper, don't pick up your calculator and expect to do everything in the calculator, okay? Number 4, factorize. Right, to factorize, first thing, always look for a common factor. Oh, we're sticking with the green, right? Okay, I'll maybe change it back to black. Always look for a common factor, okay? Some people might be looking at this thinking, oh, maybe it looks like the difference of 2 squares. There is a common factor though. Take out the common factor. Right, 3x squared minus 48. 3 is a common factor. If you take out a common factor, remember we're only looking for the 1 brackets. X squared, take away, 3 times what makes 48? 3 16s make 48. That will get you 1 mark. It's not finished. This is worth 2 marks, okay? There is something else we can do. This part that's inside the bracket, we can factorise that again, okay? X squared take away 16. The number 16 is a square number, so we're now going to apply what we call difference of 2 squares type factorise, okay? X squared, x times x will give us the x squared. 16, 4 times 4 will give us the 16, and I'm hoping you're a wee extra step ahead and you'll know what we now do to complete the answer. In one of the brackets, doesn't matter which one, we put a subtract, and in the other bracket we put a plus. Okay, it doesn't matter if you have the plus in the first bracket and the subtract in the second, that doesn't matter. However, you must have x at the start of both and 4 at the end of both. Okay. Right, number 5, okay, one of these angle questions. Right, we went over this before. There are 3 important angle facts that you must know to be able to do these questions. Okay, 3 angle facts. Let's see if you quickly remember what they are. 3 angle facts. If you have a triangle where that's the radius and that's the radius, it creates an isosceles triangle. Okay, having a wee look at this. It doesn't really look as if it's that angle fact that's mentioned here. Another angle fact that we use is when you have a semicircle, for example, there's the diameter, okay? If you have a triangle like this, that angle is always 90, okay? I'm not sure if I can see that, no. Right, it does mention the word tangent. If you have a circle and a tangent, which is a line that touches the circle at one point only, then the line that goes from the centre, which is the radius, meets the tangent at 90 degrees. So that's a wee 90 degree angle. That's the 3 angle facts you always look to try and apply in the question, okay? And remember, you've got 143 in the middle. Expect to use that. Now, without even going on and doing much in the question, let's just double check. the angle we've to find. ABC, start to A, go to B, go to C. Start to A, go to B, go to C. So it is the one here that's been shaded in. Okay? Right, let's just have a wee look. Right, 143, the bit here beside the 143 is the number that makes up to 180. North to south, the line D down to E is 180 in total. So 180, remember it is a calculator paper, but still set out your working. Okay, that gives us 37 in there. Okay, so this wee one here's 37. Now I'm going to turn my diagram, my iPad even, on the side. Alright, I'm looking at this Z shape. That wee one's 37, Z shape. That's also 37. So this one here that's 37 is the same as this one here. So that's also 37. We all right? And now it mentioned 37. Doesn't look like 37, right? I mean the number, not the size. They're only sketches. Right, so that angle there in black that I've now shaded in is 37, same as the other one, the Z shape. Right, now it mentions tangent. It's not just there for no reason. The tangent, A to B, line AB is a tangent. I'll see if I can put it in a different colour. There we go. That means this in total is 90. Now if that's 90 in total and part of it is 37, then what's the green bit beside the 37? Well, 90 take away 37 is 53. So that green bit there, I'll now colour it in green, is 53. Okay, for getting that so far, we would now have 2 marks. Right, basically a mark for 37 and a mark for 53. Let's see, where are we now? Right, 53, same at the top, 53, and now angle B, the one that's shaded in, well, 53 and 53 make 106. How do you find angle B, the one in the corner? 3 in a triangle add up to 180. 74 is the answer. Okay, remember when it comes to the exam, you write on the exam paper, just in the same way that I've shown you. Okay. Number 6. Right, Jack phoned his internet provider on 6 occasions to report connection problems, blah, blah, blah. Right, so these are the lengths of time that he's had to wait on the phone before speaking to an advisor. I bet these internet providers have had loads of phone calls over the last couple of weeks. Right, let's see. Right, calculate the mean and the standard deviation. Right, so first thing, the mean. The mean is what we get when we add them all up. Get the total. And you should be thinking what you do next. Add them all up, get the total, and divide by how many we have. Divide by 6. Okay? Let's say, use your calculator. 13, 16, 10, 22, 5, and 12. Add up to 78. Divide it by 6. The mean is 13. Okay, now I don't have enough space to do the standard deviation on this, so I'm going to turn over to the next page. I'm just going to get a wee quick note of the numbers. There we are. Right, standard deviation. To work out the standard deviation, this is where we set up our table with the 3 columns. Okay, down the left hand side of the table, I've already taken a wee note of the numbers. Okay, the numbers that we were given in the original question. These are the number of the lengths of the call times that Jack's been waiting to get through to his internet provider. Right, in the middle column, so that's the numbers that were given in the question. Let's go back. The mean was 13. Okay, so in the middle column, I mean, you don't need to label it with anything, but I like to call it the D column. D standing for the difference. Okay, so in this column we put the difference between each value and the mean. Remind ourselves, the mean is 13. We've just worked it out. So what's the difference between 13 and 13? Nothing. What's the difference between 16 and 13? 3. What's the difference between 10 and 13? I'm going to work through these quickly now. 22 and 13. Difference between 5 and 13. 12 and 13. Okay? And the third column of this table is, and I call it the d squared column, because now what we do is square each of our differences. Nothing times nothing. 3 3s. Okay, 1 times 1 is 1. So these are our differences, and a couple more steps we need to do to get the standard deviation. First thing is we total these up, okay? Total them up. Totals up to 164. 164. To get the standard deviation, we do 164 divided by 1, 2, 3, 4, 5, not 6. 1 less than the number of values. We divide by 5. Divide by 5 gives me 32.8, but the standard deviation is actually the square root of that number. The square root of 32.8. Okay? Square root of the answer, 5.7. And I would go back and double check. Does it mention anything about rounding? I don't think it does. Let's go back and check. Calculate the mean and the standard deviation of the times. These are the times, and they're the times he's been on this call for in minutes. So that's 5.7 minutes. Okay, the mean was 13 minutes. That's the average time he was on the calls for. Or that average time he was waiting for his call to be answered, actually. Right, okay, I think there's a part B. Right, Sophie also called the same internet provider to report connection problems, so her mean and standard deviation time is also given. So now we have to make 2 comments to compare. Right, so let's just make a wee note. Right, the first guy, he was Jack. Jack's mean was 13, and his standard deviation, we've just worked it out, I think it was 5.7. Right, Sophie. I'm just writing down the values so we can compare them. Her mean is 15, it's just told us in the question, and her standard deviation is 4.3. Now, we've said this before, what we are not allowed to do is simply state that Sophie's mean is higher. We can say Sophie's mean is higher, but we need to say what that actually means in real terms. You must use what are these numbers? They're about minutes, they're about length of calls. You must put those words into the answer, okay? So, let's see. Right, okay, Sophie's mean is higher. Yes, stating the obvious. Sophie's mean, what am I doing? There we go. Sophie's mean is higher, but what does that mean? Right, what does that actually mean? The mean is the average time they're waiting for the calls to be answered. So she's on the calls longer, or she's kept waiting longer. Okay, so she's kept waiting longer, we'll say. Or she's on the call for a lot longer. Kept waiting longer. Or you could say, remember, Jack's mean is smaller, he's not on the phone as long. Something like that, perfectly fine. Right, now we need to make a comment about the standard deviation. Right, the standard deviation, remember, is a measure of how varied the numbers are, how widely spread out the numbers are, okay? The lower the standard deviation, the better. The lower the standard deviation, the less varied or less widely spread out the values are. Or you could say, the lower the standard deviation, the more consistent the numbers are. So we'll say, Sophie's standard deviation is lower. Again, we must see what that actually means. So, our waiting times, because it's lower, are less varied, you could say. Or you could say, or our waiting times are more consistent. Whatever words you prefer. Okay? Right, number 7. Let's see. Carton is in the shape of a large cone with a small cone removed. The large cone has a diameter 32, height's 24, and the small cone has a diameter of 18 and the height is 13.5. Calculate the volume of the carton. Right, the volume formulas, just let's bring up the volume formulas. Oops, no, that's not the volume formula. The volume formula is here. There we go. Right, volume of a cone. A third pi r squared h. That's our cone formula. Okay, let's just check that we're going to work out here. In these questions, work out, right, wee bit of advice, work out the volume of any shape you can find. Okay, any shape in the diagram, work out the volume of whatever shape you can find. Okay, I can see a big cone and I can see a small cone. I'm going to work out the volume of each one. If we do that, this was worth 5 marks. We have got 4 marks. Okay, so work out the volume of any shape you can see in the picture. Right, so we're going to work out the volume of, the, let me take away this formula list. We don't need it anymore. Right, we'll work out the volume of the small cone first, okay? The small cone. So it's a third pi r squared h. A third times pi times the radius of the small cone. You'll see the diameter is an 18. So this is the wee cone here at the bottom I'm talking about. The diameter is 18, so the radius is only 9, half of it. And what's the height of the small cone? It's 13.5. It's in the picture. Okay? Right, get your calculator. 1 divided by 3, 1/3. 1 divided by 3 times pi times 9 squared times 13.5. I get 1.145. Please don't round it or anything yet. I know it says round to 2 significant figures. That is your answer at the end, not just now. Okay? 1.145? Oh, it's 1,145. Just ignore me. 1,145.111, we'll say. Okay, that's a small cone. We're now going to do the same for the big cone. Okay. A third pi r squared h. So it's a third times pi times the radius of the big cone. Right, here's the big cone here. The diameter of the big cone is 32. The radius is half of it, 16. Now, the height of the big cone, there's the height of the big cone, 24. Okay. 1 divided by 3 times pi times 16 squared times 24 gives us 6433, something like that. 0.982, we'll see. Okay, so there's our formulas for the small and the big cone, and I'm hoping that you know what you're going to do now. Right, so as I said, work out the volumes of any shape you can see. What is the volume of the carton? Right, the carton is the big cone with the wee cone removed. It tells you that in the question. So to get the actual volume of the carton, we do the big volume, the big cone, subtract the small cone. Okay, so we're doing the 6,433 number, take away 1145, approximately that. Okay, I haven't wrote down all the numbers with the correct decimal places. Please use these numbers that are here. Okay, I would be keeping as many numbers on the calculator as possible. When I do that, I get about 5,288.87, and then we're going to round correctly to 2 significant figures. Okay, not 2 decimal places, 2 significant figures. Let's just check. 1, 2. The 2 significant figures at the front are 5 and 2. Check the next one. It's an 8. Is it 5 or more? Yes, it is. So we don't leave it as 5,200. The 8 bumps the 2 up, so it's 5,300. And you will not get full marks unless we get the volume units. These are in centimetres, volume is in cubic centimetres. There we are. Okay. Right, I'm hoping we're okay with that. I'm going to leave you some questions to do now. Please spend the next 15-20 minutes, it shouldn't take much longer than that, doing the questions, and then come back for part 2. Remember, there is a part 2, okay? And remember, we're hoping you'll upload your work by Sunday at the latest. Bye-bye.